All right, in the day 7 lesson, we will continue our discussion of circumference and arc length, and sometimes arc measure, which is degrees, and radius. So, circumference. Circumference, there are two formulas, two versions of the same formula, really. One is that circumference is equal to 2 pi times the radius, so 2 pi r. Memorize that. Another version of the same thing is circumference is equal to pi times diameter. So if we're dealing with radius, we'll use this one. If we're dealing with diameter, use this one. But you should know them both. For number 1, we are given the radius, so let's use this one. So we will have circumference equals 2 pi times 5.7. So just put that into your handy dandy calculator. You get 35.81. So 35.81 centimeters. Don't forget your units. So that is the answer to number 1. Often try to leave things exact without rounding, but if I notice that this is already in some kind of a decimal, then usually that's a signal that decimals will be just fine. On this one, we're given the diameter. So I'm going to use this version of the formula. So I'm going to go with circumference is equal to pi times the diameter. So in this case, that would be just 21.6 pi. Okay. So really, you know, that is the answer. But it's kind of weird to have a decimal and then pi, so I think we'll go ahead and multiply that out. So 21.6 pi is approximately 67.86 feet. All right, so that's number 2. This time we're supposed to find the radius, and we're given the circumference. Well, look, if you're given the circumference, you're still going to use the circumference formula. So we're still going to use c equals 2 pi r. But since we are given the circumference, we're going to take the circumference and put it in where the circumference goes. So this is going to become 94 equals 2 pi r. And we're looking for the radius, which is this r right here. So we will just divide both sides by 2 pi. 2 pi divided by 2 pi. So these are going to cancel each other out. And I am going to get whatever I get. So I'm going to put this in my calculator. This time I don't have decimals at first, so I'm going to start out with an exact answer. So see how the pi is in the denominator? So the pi is going to stay in the denominator. Okay, so I'm just going to do the 94 divided by 2 part, but since the pi is in the denominator, it will still stay in the denominator. So, you know, 94 divided by 2, of course, is 47. So this is going to be 47 over pi inches. So this would be the exact answer. But as a decimal, okay, we could just divide. Now I could either go 47 divided by pi, and really there's the 47, so I can just say divided by pi. And I'm going to get 14.96. So that'll be the decimal version. Inches. Okay, so if I say exact, give me this one. This is exact. This is what I mean by exact. This was rounded, so there's that. There's one thing I have to point out to you, though. Going back to the 94 over 2 pi for a second. All right, so focus on this. We had 94 over 2 pi. Say if you wanted to go straight to a decimal on this. you really want to type this in as a fraction, like this. So you hit your fraction button, and you want to hit 94 over 2 pi, just like I had it written on the paper. If I do it this way, I'm going to get the 14.96 that we agreed on. Now, here's the mistake many students will make. Instead of making a fraction 94 over 2 pi, I will often see students do this. They will do 94 divided by 2 pi like that. And they'll think they're going to get the same answer, but they don't. All right? One gives you 14.96, the other one gives you 147.65. So that is completely different and wrong. So you cannot divide by 2 pi like this. The reason is the order of operations. Your calculator is just dividing by 2 first, and then it's multiplying by 3.14, blah, blah, blah. So that's why you're getting this big number. If you want to use this division sign, and again, I encourage you to do a fraction instead, but if you're just, for whatever reason, you just insist on using the division sign, then you have to put the 2 pi in parentheses. So if I do 94 divided by, and then I put parentheses 2 pi, well, then I'm going to get the 14.96 I'm supposed to. So I recommend just avoiding this by doing a fraction, but if you do use this division symbol, you have to put parentheses around anything that has more than one part to it, more than one factor. Okay, back to work. All right, so number 4. Find the exact radius of a circle with circumference 74. So that's basically the same thing we just did. Okay, so we're using c equals 2 pi r, but the circumference is 74, so we're just going to put the 74 right there. So this is going to become 74 is equal to 2 pi r. If you divide both sides by r, you're going to get, by 2 pi, you're going to get the 74 over 2 pi. And then I'm going to reduce just like we did before. 74 divided by 2 is like 36, I think. $37, yeah. Okay, so that's 37. See how the pi is in the denominator? So 37 over pi. That pi has to stay in the denominator. So that's the answer to number 4. And it says exact, which means no decimals, leave pi in your answer. Number 5, find the exact diameter given this circumference is 58. Okay, since they're mentioning diameter, then let's go ahead and use the version of the circumference that goes pi times diameter. And again, we're given the 58, so we're just going to put the 58 in for c. So this is going to become 58 is equal to pi times diameter. So if I want to find the diameter, I just have to divide by pi. So that means dividing both sides by pi, and I'm limited on space, so I'm just going to have to erase. So if I divide both sides by pi like this, then these pi's are going to cancel each other out. And since I'm doing this on a computer, I can just do this. So that means the diameter is 58 over pi. That is the exact answer. Okay, I'm forgetting my units. This was centimeters, and this one is feet. Okay, I guess I should put it over here. All right, moving on. Number 6, find the exact circumference when the diameter is 26.3. So this says exact, so even though it says a decimal, I'm going to still leave pi in my answer. Since they're mentioning diameter, then again, I'm going to use the version, of the formula that says circumference is pi times diameter. I'm going to use this. But this diameter is 26.3, so I'm just going to put my 26.3 right there. So that's just going to immediately give me that the circumference is 26.3 pi. That's it. Okay, just put this pi d, that's pi times 26.3, which we usually would write as 26.3 pi. Okay, number 7. Find the circumference. We're given the radius. So this time we're given the radius, so we will use the version of the formula that involves the radius. So we'll go back to 2 pi r. I don't know why my voice is so scratchy this morning. Let's see. So the radius, so this is the radius. So I'm just going to put this in for r. So this is going to become, I have room over here, so I'll do it here. Circumference is equal to 2 pi times 31.9. And they want it to be exact. So see the word exact. So I'm going to leave pi alone. So I'm just going to do 2 times 31.9. So that's 63.8. So that is going to give me that circumference is 63.8 pi. And that's it. All right, moving on. Yeah, 1 through 10, and then, okay. So now number 8. We're supposed to find the length of arc AB. So always pay attention to whether you're finding length or measure, because that's two different things. Arc AB is this arc right here, the minor arc. Okay, so we are trying to find this length. We'll just call it X, but so imagine that this is a piece of yarn. We're trying to find the length of that yarn in inches. Anytime you're dealing with arc length, your best bet is to set up a proportion of this form. Part over whole equals part over whole. On this side, we're going to do degrees. And on this side, we're going to do length. Okay, so let's do that. So on the right-hand side, part over whole degrees. The partial degrees are 145. The total degrees will always be 360. Okay, so part over whole degrees. Now on the left side, let's do part over whole length. Now the partial length is this yarn. So let's call that X because we don't know it. But the total length, there's a name for the total length of a circle, and that is called circumference. And circumference, so circumference is always going to go here. So that is, the formula for circumference, as we've been saying, is 2 pi times the radius. So I'm going to go ahead and put circumference here, 2 pi times 14.2. Okay, I always recommend reducing this fraction first before you do anything else. So 145 over 360. That's 29 over 72. I would go with that. 29 over 72. And this is X over, maybe I'm just going to leave this for now. I do not like to round things until the very, very end. So, I'm just going to leave this just like it is for now. 2 pi 14.2. I'll deal with it later. Now, as we cross multiply, it's time to cross multiply. I'm going to have 72x, okay, that's this diagonal, is equal to 29 times this mess. So it's going to be like 29 times 2 pi 14.2. Okay? Now, you could go ahead and put this in your calculator now if you want. So we're going to find this value, and then we're going to divide by 72. So let's do that. 29 times 2 pi 14.2. Okay, so 29 times 2 pi 14.2. Whoops, I missed a 4. 14.2. Okay, we get that decimal. Now do not round this, just leave it in your calculator, because like we said, our next step after this is going to be to divide both sides by 72. That's going to be the next thing we do. Okay, so let's just go ahead and hit the division button. So divided by 72. Okay, so this way the only rounding that we're doing is at the very, very end. That's the way it should always be. So this is 35.94. All right, and that is your arc length that we wanted. Okay, so number 9 and 10 are basically the same thing over again. So I'm going to go through it, but I'm going to see if I can go through it any faster than I did before. So again, part over whole equals part over whole. On the right-hand side, we're going to do degrees. So that will be 130 over 360. On the left-hand side, it's going to be the partial length over the whole length, or circumference. So the partial length is what we're supposed to find. The whole length is 2 pi 15.4. Okay, the circumference. Okay, 130 over 360. I think we should reduce that. So 130 over 360. That's 13 over 36. All right, that's basically, we crossed out the zeros here. All right, but fine, 13 over 36. And here we have x over 2 pi 15.4. So it's time to cross multiply. So if I do this diagonal, I'm going to get 36x. If I do this diagonal, I'm going to get 13 times 2 pi 15.4. All right, let's just leave this all like it is for right now. To get x by itself, we need to divide both sides by 36. Okay, so we're dividing by 36. Okay, so to get x, we just have to put all this in the calculator. Okay, so in my calculator, I'm just going to type all this in. So in fraction mode, here we go. 13 times 2 pi 15.4 over 36. Okay, we can just put all in the calculator at once. So that's going to give me 34.94. So 34.94. Okay, so that is the arc length once again. All right, number 10, same thing. So once again, we're going to do part over whole degrees equals part over whole length. All right, I'm going to set it up right here. Part over whole degrees, so that's 67 over 360. All right, now part over whole length. The arc length, AB, we don't know it, call it x. The total length is the circumference, 2 pi r, so that's 2 pi 30.8. Okay, let's see if we can reduce 67 over 360 or not. Okay, 67 over 360. Nope, that doesn't reduce. Nice. Okay, so we just have to deal with the big numbers. Alright, we can handle it. Okay. Alright. So if we cross multiply, I'm going to get 360x over here. Alright, so I have 360x equals. Now, so that's this way. This way, I'm going to have 67 times 2 pi 30.8. Okay, I'm just setting it all up. To get x by itself, I'm going to have to divide by 360. Alright, so that would look like this. Alright, so that's going to get x by itself. So I just need to put all this in my calculator. Okay, so here I go. Fraction mode, 67 times 2 pi 30.8 over 360. So that's 36.02. Okay, I've been forgetting my units. This was meters, this was centimeters, and this was inches. Alright, you should always include your units. Alright, all three of those problems were really exactly the same, just different numbers. Alright, but these, here we got circumference, here we have radius, and here is arc length again. So number 19 will be the same as what we've been doing. But 17 and 18 are slightly different. Okay, now when they ask you to find the circumference, but they don't give you the radius, that means that see how they're giving us the arc length? Alright, this 12 centimeters, that is the arc length. It's like the thing that we found on these other problems. So arc length is a clue to you that we're going to do this part over whole equals part over whole thing. So just be aware that every time we've done these three problems, at this position we always put 2 pi r, because this is the circumference, okay? Because we did part over whole, and the whole length is the circumference. So when we do this problem, when we do our part over whole, okay, when we're doing part over whole equals part over whole, as we've seen over and over again, this whole is always 360, all right, because that's always the total degrees. But this whole is always the circumference. So as we look for the circumference, just understand that we're looking for this. Now, as we do the part and the part, this is the partial degrees, which is 85. And this part is the partial length, or the arc length. And that partial length is 12. So this is the setup. Part over whole degrees and part over whole length. The whole length is the circumference. Do not use x for the circumference. Use c. Otherwise, you're going to forget what you have, because sometimes we're finding the radius and then we have to plug that back in. Sometimes it's the arc length, but this time it's the circumference. So if it's the circumference, please use c. It will help you keep track of what you're doing. Let's see if 85 over 360 will reduce. And of course it will. But 85 over 360. 17 over 72. Let's use those smaller numbers. So 12 over c equals 17 over 72. So now we cross multiply. So in this direction I have 17c. And in this direction, I have 12 times 72. So that's 864. And then I'm going to divide by 17. So these are going to cancel out. 864, and I can just go divided by 17. So that's 50.82. Okay, centimeters. So that is the circumference. Okay, on this one we're supposed to find the radius. Okay, but they did not give us the circumference. So basically we're going to have to find the circumference like we did before. Here's one way you could sort of do it. We're going to do that part over whole equals part over whole thing once again. So part over whole, let's see, I just want to make sure I have lots of space. All right, as I do my part over whole, of course, on the one hand, we're going to have degrees. So I'm going to have 132 over 360, part over whole. Now, on the other hand, I'm going to have part over whole length. So the partial length, they gave it to me. It's the arc length is 14.2. So that 14.2 will go here. That's the partial length. Now, down here is the whole, it's the circumference. So I could put C here. But since we're trying to find the radius, it might be better for you if you go ahead and put 2 pi r here, which is an expression. It's the formula for circumference. And the reason I'm doing that is because then I get my r, which is what I'm looking for. So if I were you, I would reduce this side, the 132 over 360. So let's see, 132 over 360. That's 11 over 30. So let's go with that. So what we have now is 14.2 over 2 pi r is equal to 11 over 30. Okay, so we just have to cross multiply. Okay, so if we cross multiply, we are going to get, let's see, 2 times 11 is 22. So it'll be 22 pi r is equal to, let's see, what's 30 times 14.2? $426. Now remember, we're looking for r, so I just have to get r by itself. So if I want to get r by itself, I can just divide by 22 pi. All right, so these cancel out, and that's going to get r by itself. So I can put this in my calculator. I'm curious what an exact answer would look like, first of all, in case I could have been asked for an exact answer. So 426 over 22. All right, that's 213 over 11. So if I wanted an exact answer, this is what it would be. All right, it would be 213 over 11. Over 11 pi. See how the pi is in the denominator? It has to stay in the denominator. So this would be the radius. Of course, if I want a decimal, the best thing to do would be to just put that pi right in there. So we had 400, let me just start over. So we had 426 over 11 pi. No, we didn't. We had 426 over 22 pi. Okay, so that is 6.16. So that would be the decimal form of this answer. All right, and this is inches, so I should include the units. All right, number 19. I think this is the last problem. So this time, so we're back to finding arc length again. So this is really nothing new. It's like these three problems that we did up here. So once again, with the part over whole equals part over whole. One more time. So part over whole degrees is 118 over 360. Part over whole length. We're being asked to find the length of arc AB. So we don't know the length, so we'll call it x. The whole length is the circumference, which is 2 pi r. So that's 2 pi times 17.6. Right, from right there. Let's see, 118 over 360. It's 59 over 180. All right, so I have x over 2 pi 17.6 equals 59 over 180. So I just need to cross multiply. So if I cross multiply right here, I'm going to get 180x equals, and I'll have 59 times, that's a 9 by the way, 59 times 2 pi 17.6. I do not like to have decimals until the very end, so I'm just going to leave this alone for a minute and go ahead and just divide by 180. Okay, so if I divide by 180, so I'm going to get x equals. Now I can just put all this into my calculator. All right, so here I go. So fraction mode, and I'm just typing all this in. So 59 times 2 pi 17.6 over 180. So that is 36.25 if you round properly. And this is feet. Okay, that is how you do that. All right, I hope this has been helpful. If so, please give me a thumbs up or hit that like button. I really appreciate it. I know this stuff is kind of challenging for a lot of students. Practice, practice, practice. Now, if you found yourself just sort of watching the video and just following along with me, it is very important that you go back and try to do these problems on your own. So you don't really, just watching and understanding me do it is not the same thing as doing it yourself. So please go back and do the problems on your own if you were not able to do them on your own. All right, I will see you on the next video.